Hi, my name is Mike, and along with my colleagues Octavi, James, Raoul, and Per, I'd like to introduce you to a couple of exciting projects that we're launching in Indiegogo. You'll notice from the title of our project that we're starting something called the PHASTT network, which, if you're wondering, stands for Possibly Hazardous Asteroid Search and Tracking Telescope. Right now, we're planning to build two inexpensive but capable robotic observatories to be located in Spain and Peru. What is the purpose of PHASTT? Well, in short, these telescopes will search for objects that could impact the Earth. As well as searching for asteroids and comets, the PHASTT network will also provide positional information on a large number of previously discovered objects. This important function will help to refine the positions of objects with uncertain orbits, improving our certainty about where they'll be in the future and whether they may pose a threat to Earth. And when it's not doing either of those two things, PHASTT will be able to use its colored filter set to help determine the composition of the asteroids that come closest to Earth. It's kind of like the icing on the cake, but this bit of our project will help us understand what these things are made of and how we can either explore them in the future or at the very least mitigate the hazard presented by an impact. Not only will the PHASTT telescopes be doing some really good planetary science, but they'll also do some neat exoplanetary science. The wide field of view of the PHASTT telescopes means that they'll image a large number of objects in a single frame, tens of thousands in fact. And since they'll image those objects repeatedly over the course of hours, days, and weeks, they'll be able to tell us how objects in the night sky are changing over time. A common question from people is, just how sensitive is this telescope? That's a good question, but it has a number of answers depending on who you ask. The astronomer in me wants to say something like, we expect to be able to image objects as faint as 20-second magnitude at a signal-to-noise ratio of 3 in a 60-second exposure. But what does that really mean? Well, imagine that you had good eyesight and could see a lit candle from 500 meters away. That's quite good, but the PHASTT-1 telescope, with its much larger light-gathering area, could see that same candle from somewhere around 100 kilometers away. Now, although that sounds impressive, we're not actually looking for candles, we're looking for lumps of rock and ice that are on a collision course with Earth. So expressed in terms of space rock size, PHASTT-1 will, roughly speaking, be able to detect an object greater than about 5 meters in size approximately 1 day before impact, or a 50-meter object about a week before impact. Technology today has advanced to the point where most of what we need can be purchased off the shelf. As a result, much of what we're designing is plug and play. And this means that not only are the risks associated with this project low, but that we can complete the project in a relatively short period of time. Ideally, we'll be fully operational by next summer. So what do we need from you? Well, if you could take a look around the Indiegogo website, see what we have to offer. We've got some great perks. It'd be great if you can contribute to the project to make this happen. Thanks, take care, and have a great day.